Some people think that physics isn't very exciting, but we encounter physics principles like potential energy and kinetic energy all the time. A situation like this might lead you to think about the idea of energy. Let's assume that the only forces on the roller coaster car are the normal force and gravity. How does the normal force affect the speed of the roller coaster car?
Correct.
The only force that changes the speed of the car is gravity, which is a conservative force. When conservative forces alone act on a system, this expression for energy holds. The change in kinetic energy delta K plus the change in potential energy delta U is 0. The roller coaster started with an initial velocity of 0, so delta K equals the kinetic energy. Let's define the y-axis. y1 is the height of the starting point, and y2 is the present height. The gravitational potential energy is the mass, m, times the acceleration of gravity, g, times the height, y, plus a constant u0, which is the value of the potential energy u at y equals 0. At the starting point, y equals y1, and at the present position, y equals y2. From these two equations, we obtain the following expression for the initial and the present potential energies, u1 and u2. The change in potential energy is therefore equal to mg times the difference between y2 and y1. Note that the constant u0 drops out. Potential energy expressions always include a constant, but because only differences in potential energy are important, the constant can be set to an arbitrary value according to what is convenient. Combine these expressions to give the change in kinetic and potential energy. We can solve this to obtain v. Thus, in the absence of friction, the car's velocity only depends on the change in height from its starting point. The expression shown is true for the case of conservative forces. The mechanical energy E is the sum of the kinetic energy K and the potential energy U. With this definition, we see that the change in mechanical energy E is 0. If the change in the mechanical energy delta E is 0, then E is constant, or, in other words, energy is conserved. What about non-conservative forces like friction and air resistance? The mechanical energy lost due to friction is converted into thermal energy. If we include the internal energy E sub I of the system in the total energy E, we can state the general principle of the conservation of energy. Keep in mind that the mechanical energy K plus U is conserved only if there are no frictional or other dissipative forces. Let's consider an example of calculating the force from the potential energy. The potential energy of a molecule with two atoms as a function of their separation x is given by the equation shown. A and B are constants. The force is negative the derivative of the potential energy. Evaluate the derivative to get the force. When the distance x is small, the force is repulsive, and when x is large, the force is attractive. At a certain value, the force is 0. This is the equilibrium position. Let's solve for the equilibrium separation. At this separation, the force is 0. This equation can be rewritten as shown. Finally, solve for the equilibrium separation. The equilibrium separation is the sixth root of 2a divided by b. Because the force is minus the derivative of the potential energy, the force is 0 at x corresponding to the minimum of the potential energy function. A pendulum has kinetic energy and gravitational potential energy. According to the conservation of energy, the total energy as a function of position is conserved. In other words, the sum of the kinetic energy and the potential energy is constant and equal to the total energy. As the pendulum swings downward, gravitational potential energy decreases while kinetic energy increases. As it moves upward, potential energy increases and kinetic energy decreases. The kinetic energy goes to 0 at the points where the pendulum stops and turns around. Thus, if a pendulum is released at 0 velocity, it should return to the same point with 0 velocity. Let's see if conservation of energy works. The pendulum returns to its starting location, but does not go beyond it. Energy is conserved.
I'm a believer.